Hello students, welcome back to lecture 5 of arrays chapter. So in today's class, we will be discussing a very important searching algorithm, that is binary search. In previous class, we have done linear search. So this is the second type of search which is there in your portion, very important. So we will be understanding the mechanism, how to apply binary search, how it works on a given set of array, what is the condition required to apply binary search, and we will see the use of binary search in an integer array in ascending order as well as in descending order. Okay, so coming to the mechanism part, I will explain you directly in BlueJ while explaining the program and the condition to apply binary search. Here you can apply binary search only on arrays which are in sorted order. An array must be in either ascending order or descending order. Then only binary search can be applied. Okay. If you remember, in linear search, there is no such condition required. Linear search can be applied on any set of array, irrespective of its order. But for binary search to apply, it is necessary that an array must be in order, either ascending order or descending order. Okay, so that is a very important condition with respect to binary search. Now, with respect to understanding the mechanism, for example, if you visualize that this is an integer array containing elements in ascending order. So internally, your elements will be stored in this fashion, right? The elements of an array are stored in contiguous memory locations in a single row or in a column. And each element is given an index value starting from 0 till L minus 1, right? Now, in binary search, we will be using three variables, L denoting left, storing the left index, the starting index of the array, that is 0, and we'll be using a variable R for storing the rightmost index value. In this case, it is a.length minus 1. And we use one more variable M, which stores the mid index, which we get by writing L plus R by 2, which gives you the mid index. Fine. So the remaining part of search is like your linear search, how you start your linear search. You create an array, you input elements into the array, then you input the element to be searched, right? The input an element to be searched, input n to be searched. So if you are seeing the binary search for the first time, just refer linear search first, because all the initial steps of creating an array, inputting elements into array, accepting an element to be searched, that will remain common in any type of search. Now from here on, we apply binary search for finding this element into the list, right? So now verbally, let me explain you the binary search, and then I'll explain same thing in a program. So here, once we will be calculating the mid index, here L is initialized, R is initialized, and M is the variable containing L plus R by 2. Okay, these all are three integer variables we will be using in binary search. L initialized to 0, R initialized to L minus 1, and M will be just an integer variable. Then you will calculate M is equal to L plus R by 2. Okay. Now you will compare the element which you are searching, with the element at mid position. Okay, there are chances that the element what you are searching is exactly the mid element here. Now, in this example, your 0 plus 9 by 2 is 4, right? Int by int gives you int. Therefore, m will be, this will be your m. M will be your 4. The first time your m will be 4, right? It's 0 plus 9 by 2. Many of you will say it is 4.5, but then whenever we do functions on integers, the answer is also an integer. So do not take decimals, just take the integer part of the fraction if you get. Right, so your m is 4. Now, the first possibility is the element which you are searching is exactly the element at mid position. Suppose your n is 50. So, with this condition will be true and your n will be found at position m plus 1. So, you can just write n found at position, I'm writing in brief, at position, say, m plus 1. Why we write m plus 1? Because we will be, when we display the output, we always write in general language, which is understood by everybody, and not only those who know about indices and all. So we write m plus 1. Now, for example, if your n value is 50, what is the position of 50 in general? It is 5, right? 10 is at first position, 20 is at second, third, fourth, fifth. So we will make m plus 1 so that it is displayed in general form. Okay. Now, there may be another possibility. See, if this is false, suppose, then there may be another possibility, that is, if n is greater than a of m, the element which you are searching, if greater than a of m, it's possible, right? So if it is true, what we do is, see, if your n is greater than a of m, for example, if your n is 80, suppose, now 80 greater than a of m, now in this case your m is 4, your m is 4, so a of 4 is 50, right? So if your n is greater than a of m, that means the element which you are searching is to the right of m. The element which you are searching is to the right of m. So you will shift L to m plus 1 now. So if this is true, your L will be shifted to m plus 1. Okay. And now, so that the searching takes place only in this part of the array and the left side is ignored. Fine. Depending on the position of the element you are searching, the array is divided into parts and the searching takes place in a particular part and not in the complete array. Right? So this is the second possibility. Now, there may be one more possibility here, that is, if n is less than a of m, if n is less than a of m, that means what? That means the element which you are searching is less than a of m. So the element is to the, so if this is the case, what we do is we shift r to m minus 1. R will become m minus 1. Okay. And now the searching will take place only in this part of the array and this side will be ignored. Are you getting the logic? And see, this part is the binary search, what I have explained you. This is all binary search logic. So this will be repeated n number of times depending on whether element is found or not. So this all will be placed within a while loop with condition L less than equal to R. And each time your M will be calculated, and then the element you're searching will be compared with element at mid, and depending on these three conditions, either your element is found or your L or R will be shifted depending on whether element is to the right or to the left of your mid. Okay, so this is all within a while loop. So from here again the control will go to this, and again your mid will be calculated, the three conditions will be checked. Either you may find the element, its position will be printed, or your L or R will be shifted. So with this logic, what happens is, see, if you imagine an array of suppose 1,000 elements. So using binary search, first iteration will search all the 1,000 elements for mid and accordingly. Now in the second iteration, the number of elements will be halved. Now in the second iteration, the searching will take place only in the 500 among 500 elements. Third iteration, 250 elements, then 175. Like that, it will go on reducing. The size of array reduces. So you can understand that binary search will be faster compared to linear search. In linear search, you do searching in a sequential manner, right from first element till you find or till the end of array. But here in binary search, you do not compare each and every element. You find the mid position, compare n with element at mid position. If it is same as mid element, you got the element. Otherwise, you will check whether your element to be searched is to the right or to the left of the mid. And accordingly, you will shift your L and R and continue that process till the element is found through the mid index. So finally, at one point of time, this condition will become true and this will give you the output. Got it? So this is the logic of binary search. Hope you understood. Now I will show you this through a program in BlueJ. Just a minute. Yeah. So please go through the question here. The question is, write a program to input 10 integers in ascending order in an integer array. Now, using binary search, print the position of the element accepted from the user or the element which you want to search. Also, if the element is not found, print an appropriate error message accordingly. Okay, so this is how you will be asked a question on binary search. Now, sometimes in binary search, they will ask you to initialize the element. So depending on whether you have to input the elements or initialize elements, you can do it accordingly. If you are asked to initialize, then instead of doing this, you will directly initialize elements using this flower brackets. This is direct initialization of the elements. When it is given in the question to initialize elements with the given set of elements. If the elements are given in the question, then you can directly initialize the elements into the array. And if it is asked to accept, then you can follow the normal procedure. So that input part, keep apart, and let's focus on binary search logic, right? Now here, as usual, here we create an array for storing 10 integers. Okay, the syntax data type array name with square bracket is equal to new data type with the array size. This is the syntax for creating the array. So 10 memory locations, that is 40 bytes, will be reserved for storing 10 integers. Okay, and here we use these variables flag equal to 0, which helps us print error message, and left L equal to 0, R a dot length minus 1. See, if we use general thing, it will be true for any array, any binary search program. You can even write this as 9, but then this depends on array size. So you have to refer array size and write accordingly. But if you use general a dot length minus 1, you can just write it for any array. Okay, now, yes, so R is a dot length minus 1 and M. So here we use three variables, L storing the first index, that is 0, R storing the last index, that is a dot length minus 1, or you can write 9 as well, and M for storing the mid index. We need to use that variable in the loop, so we declare it out of the loop this way. And then if you are asked to input elements through scanner object, you can do it like this. And if you are asked to create an array, then you don't have to know this part and this part. You can skip and write the declaration and initialization both at once like this. Okay. So this part is, I think it is clear to all of you. Depending on the question, you have to decide whether to initialize the array while declaring directly or to input elements through the scanner object. After that, we accept the array element to be searched and store it in a variable n. Okay, always use short and related names as far as possible. Do not give lengthy ones, no, unnecessary. So keep using short and related names for the variables in a program. Okay, so this was all about the declaration and initialization part. Now starts our binary search logic. Let me put up this part. Yeah. Yeah, so till here, I think you understood. So let me scroll it up. Yes. So now, here we accepted the element to be searched. Now this is, here we are using a while loop because we don't know how many times we are going to have this iteration. Therefore, we use a while loop with condition L less than equal to R. This will be true if we are using an array, because L, which is 0, and R, the last index. So obviously L will be less than equal to R if we are using an array. Now, inside the while loop, we calculate M, which is L plus R by 2. Make sure you put L and R in a bracket. If you write L plus R by 2, what will happen? It will calculate R by 2 and add this to L. So please do not use this and use the bracket here. L plus R must be within the bracket by 2. Now, as I told you, there will be three conditions arising. The first condition here, you will be comparing the element to be searched with the element at mid position. And if it is true, that means you found the element. So you make flag 1 and you display the position of n as m plus 1. Okay. And if the elements are unique, you can use break to come out of the while loop because you found the element, right? So this is, if your first condition is true, all this will take place and break will shift control out of the loop. So no further searching happens and the program comes to an end. Now, in case this is false, then there will be two other options, that is, if n greater than a of m. See, if this is false, then these two conditions arise. The second condition, that is, if n is greater than a of m. Now, since elements are in ascending order, you have to visualize an array in ascending order and check if n is greater than a of m. That means n is to the right of m. So what you do, you shift L to m plus 1. With m, we are already comparing. So L will be shifted to m plus 1 and R will remain same. Okay. If this is also false, then the third condition will come into picture. If n is less than a of m, that means the element which you're searching is to the left of m. So R will be shifted to m minus 1. Okay. So out of these three conditions, any one condition will be true. Accordingly, either you get the element, you come out of the loop, or your L or R will be shifted. And then here comes the end of loop. So from here, the control will again go back to while loop. Again, this will happen. Again, your M will be computed. Again, these three things will happen. So your array will be continuously divided into parts. The searching and all that keeps happening till this becomes true at one point of time. So finally, this is going to give you the output. Okay. So these two conditions, see, this is all very simple, same like your linear search type. But here, when you come to these two conditions, please do not by heart and write, just visualize the array, think and write the condition accordingly. Okay. Because here is the place where mostly children commit errors as they by heart and write. So just imagine an array in ascending order and check whether your n is to the right or to the left. Accordingly, shift your L and R. Okay. And finally, this we are using for printing the appropriate message. If flag equal to 0, that means element not in the list. So you can print the error message. So if flag remains 0, that means this never happened. That means this never happened. Okay. The same concept we had in linear search also. So you can refer back in case you want it again in detail. Okay. So this was binary search with ascending order on integer type elements. So you can apply it for float, characters, double, integers, any type of array. Right? So just practice doing this. I will show you the output. Just a minute. Okay, here there are 10 elements. If I make it 5, so that I have to enter less number of elements. So, if we use general terms like a dot length and length minus 1, then even if you change the size, it won't matter. You don't have to change in the remaining program, as I have used the general limits. Okay. Binary search 1, right click, call the function, enter array elements in ascending order. Now, remember the order. For example, give me 25, 45, 68, 79, and 90. Okay, these are my 5 elements. Now, enter an array element to be searched. Suppose I give 79 as the element, right? So, element 79 found at position 4. You remember I have written m plus 1 so that I get the position as general position. Okay, so this is your binary search. Let me give you one more input. For example, if I give 10, 20, 30, 40, and 50, and if the element I give is not in the list, suppose. So It will give search unsuccessful, element not in the list. Okay, so this is your binary search with ascending order elements. Okay, so please, okay, I'll just go back to the main sheet. Just a second. Yeah, so you can take up this exercise. Write a program to input marks of n students of a class in ascending or descending order. Using binary search, print the position of the marks accepted by the user. It can be any value, right? So once you understand the logic of applying binary on ascending order elements and descending order elements, later we can do some more application-based programs, right? So here n students is given. So you have to first accept n, the size from the input. First accept the size, input size, input the size of the array, the number of students. Then you create an array of size n, then input elements into the array, then input element to be searched, input element to be searched, and then apply binary search for printing the position of n in the given array. Okay, so practice both in ascending order and descending order. In both these, all other things will remain same except for that last two condition, condition 2 and 3, where we had n greater than a of m. These two conditions. Here, this will change. Like this also will remain same. Only that L equal to and R equal to, that will change. If it is in ascending order, what we did, same thing will be written. You have to write same thing. If it is descending order, just visualize an array in descending order and then think if n is greater, which side of array it is and what you need to shift. Okay, this you need to try. If any doubts are there, we'll have it in the next. Okay, so please do it in BlueJ. Just listening, understanding will not work. You have to practice doing it in BlueJ. Fine. Okay, so with this, we come to the end of today's session. Hope you got this logic. Okay, please practice it. Thank you, all of you.